Okay, ladies and gentlemen, we're going to start with the confidence intervals. Problem number 1 tells us that we want to reduce or decrease our margin of error by a factor of 4. The thing to remember here is that if we want to reduce by a factor of 4, because we take the square root of our sample size, that factor that we're reducing by has to be squared. So in order to get our sample size up to snuff, to make that 1/4, we have to remember to square that factor. Next question. This is an interpretation problem. By this point, I expect that you can all correctly identify the interpretation that is correct and incorrect. So I'm not even going to give you any hints on that. Next problem. We are asked to create a confidence interval. So it's a 98% confidence interval, so we need to find an appropriate z-star value. For 98% confidence, that means we want 0.98 in the middle. That leaves 2% left over. That 2% is 0.01 in either tail. And we need to correctly identify the z-star that goes with that. Our statistic, or our point estimate, is 201.5, plus or minus whatever z-star we get for that critical value. They give us a standard deviation, and they give us a sample size. So we need to plug in our z-star, sample size, and our n. Number 2 is very similar to the first problem that we looked at, where they tell us that we want to reduce the error by 1/10. So in order to account for that, we need to square that factor. We need to remember to square that factor that we want to reduce by in calculating the appropriate sample size. The next problem. Carlos plans to use a test for the difference between two population proportions, P1 and P2. The random sample he collects, drawn from very large populations above 50, and have sizes N1 and N2. His null hypothesis is that P1 minus P2 equals 0. This is important. Based on that null hypothesis, we can pool the data as if we drew one large sample from a single population. And because of that technique, we are then able to use a different formula for the proportion. Okay, and so using that fact that we're able to pool the data as basically one large sample from a single population will tell us which of these is the appropriate formula. The next problem. Which of the following statements is true? These are all, you just need to go through and identify whether each statement is true or false. Okay? I expect that you would know all these at this point, so I'm not going to give you any hints beyond that. Next question. 900 high school freshmen were randomly selected for a national survey. Among survey participants, the mean GPA was 2.7 and standard deviation was 0.4. What is the margin of error? Notice that they've only asked us to calculate the margin of error, not a confidence interval. Remember, the margin of error is going to be a z or a t-star. Because the sample size is so large, 900 is a very large sample size, we can approximate the t-distribution with a z-distribution. So we can use a z-critical here. Large sample means that we can approximate with the normal distribution. Which means that we will be using a z-star, And 95% confidence, we all know the z-star for that is 1.96. Okay, so that takes care of the z-star value. The other piece of the margin of error is the standard deviation, and that you would need to calculate. The standard error, which is the standard deviation over the square root of n. So that's the standard error times your critical value. That together gives you your margin of error. Suppose we want to estimate the average weight of an adult male in DeKalb County, Georgia. We draw a random sample of 1,000 men. Again, that 1,000 men. We have a very large sample. A sample size so large, we can approximate with the z-distribution. Here we are actually asked for the 95% confidence interval. So we're going to have a statistic plus or minus the margin of error. I'm not going to give you any hints beyond that because we just did a very similar problem. The next one is a proportion problem. Okay, proportion problems will always be z-stars. Here we are not just setting up the confidence interval, we actually need to get the range. So 99% confidence, we know that the z-star critical for that is 2.575. And the rest of the information that we will need will come right from the problem. It's going to be p hat plus or minus z star times the square root of p hat times 1 minus p hat over n. The next problem, suppose a simple random sample of 150 students is drawn from a population of 3,000 college students. Among sampled students, the average IQ score is 115. The sample size isn't that large. It's big, but not super big. And we're dealing with means, not proportions. Therefore, this will be a t-distribution problem. And we need to identify the correct t critical value. Remember, our degrees of freedom will be sample size minus 1. So our sample size is 150 minus 1 is our degrees of freedom will be 149. Excuse me. Once we have our t-star, we just need to fill it in. And the final problem for today, which I forgot I don't have on here, but this is a difference between two means. Difference between two means will be a t-distribution problem. So we need to find our t-star value. For the last problem, you need a t-star. Your degrees of freedom will be your sample size minus 1, so it will be 21. And they give us the standard deviation in a slightly weird form. This value that is your standard deviation difference. Okay? So you just take that and divide it by your n minus 1. Take the square root of that. That concludes the hints for this homework assignment.